So here is the next video in the engineering and project management section. Today we're gonna do the road construction project. In the last video, I draw the road map and the material what we're gonna be use. It's called the subgrade and then the sub base and then the running course. So the project name is a 5 kilometer road. It's in northern Ontario. So what it is when we come to the project management, so initiation mean that what are the acceptance criteria, the map. We have to draw everything and acceptance criteria and the standards of the customer, and then we sign the project charter according to PMBOK. It's a written paper where we draw the work breakdown structure, calculate the cost, put the risk, what will be the benefit of the road. The benefit of the road will from this road almost like whatever the localities of northern Ontario there, 3-4 villages may be benefit from this in future, and the agricultural product will increase, farming will increase, and these are the benefits. So you can write down initiation of the project. Next step is planning. So in planning, first step is scope. Scope is, this is the most common word I listen in project management and every, what are the scope, what. So actually the scope is all the work done to achieve the project, to achieve the objective. And what in this case, in our case, all the work done to construct a 5 kilometer road in northern Ontario according to the acceptance criteria of the customer. So here is what scope. We start planning from scope. It's a work breakdown structure. We the scope, the work we have to done, we divide in activities, in work packages. So this is work breakdown structure. Number first, I put the subgrade, sub base, base course, and running course. In the middle, I put finance, HR, and site office. Well, in the subgrade, we do leveling. I already discussed with you in the last video, and then we do the compaction. In the sub course, we put the sand and gravel. Then we do again the compaction. It's 22-inch. And then in the base course, we do the gravel and do again the compaction. And then the running course, we do the asphalt and fine gravels, half-inch or something, little bit, 2-inch. And then the painting. Painting mean you saw the yellow line. When you are driving, there is a yellow line. If it's a single road, you cannot cross. You should stay on your right side or left side up from that yellow line. And the dotted line, you can share it. And there is a bike line. Excuse me. So what is it? Let's calculate the duration. So the subgrade, according to my calculation, will take 25 days. The sub base will take 35 days. And the base course of the road will take 46 days. And the running course will take 10 days. So what is the schedule in short words? Because you guys are going to be, so 25 days plus 35 days plus 46 days plus 10 days plus 20 I put extra. We call it as emergency or a contingency in the schedule. We do it. So the total days I got 136 days, but these are the working days. You're gonna exclude in your MS project when you're doing in Microsoft project. So 2 days in each week, like Saturday and Sundays, holidays in Ontario. Like in when you remove, so 22 days we got per month is a working, or 20 days. So 6 months is the period, including 20 days extra as emergency. So this is our schedule, and what will be the cost? When I did calculate the cost, so the subgrade will cost $12,000. The second, the sub base will cost 46,000. Base course will cost 75,000, and running course will plus painting will cost 60,000. 50,000 is our site office and survey cost and all these things. And 43,000, what is 43,000? 43,000 is a 10% is the contingency fund or emergency fund. Let's say if some activity cost more, 5,000-6,000, then we will put there. If there is a delay because of raining in the schedule, so we're gonna put 5,000-6,000 extra. So this is 10%. So our actual cost is 430,000, and plus 10% is 43,000. So what is the total cost? The budget 473,000, and the schedule is 6 months. So that's what what we did in the planning. So now the budget is 43,000. Focus on this, and the schedule is. So next stage is performing. In the performing stage, we have certain equation. We call this plain value, earned value, and actual cost. Plain value is the budgeted cost at completion. Earned value, what you have done, that you can convert to dollar value, and actual cost, what you are spending. So what is earned value? Earned value, let's say, when we complete the 75% of our subgrade, and we gonna calculate what we have done so far. So what was our plain value budgeted cost at that time minus the actual cost. So if it's positive, we good. If it's negative, so we spending more. CPI, cost performance index, is also give you an idea when you divide earned value divided by actual cost. So if it's negative, so you are like spending more. If it's positive, then it's good. If it's equal, it's okay. Schedule performance is earned value minus plain value. If you are ahead of schedule, up behind the schedule. Quality control, we do what are the standard and the quality check, we do what the customer told us, high quality, high grade standards, and then we close the project. So handover project, and the road is constructed. So this is Han Imtiaz. So here is another if sometime if as an engineer or as a project manager, you want to calculate how much, like how you can calculate the cost. So let's say the total area 16,400. If you go to the last video, multiplied by 32.8 is the width, like 5 kilometer multiplied by 10 meter, or 6,400 feet multiplied by 32.8 feet will give you the area 537,920 square feet square. And the subgrade I'm calculating for a sub is 10 inch. When you convert 10 inch to feet, so it's 0.83 feet. So what the volume is actually the area into the thickness or the height. So 448266.7 feet cube. And now the density, mass per unit volume, it's maybe like a local material, dolomite, limestone, sandstone, and clay, some type like this. So I took like 12 feet cube per ton. It's called tonnage factor also, it's called density also, mass per unit volume. So how much tonnage we need for this 10 inch thickness of the subgrade? So divide the volume 448,266.7 feet cube divided by 12 feet cube per ton. So we got 37,355 tons of material for the subgrade 10 inch thickness before compaction. After that we gonna do compaction and layering. So 37,355 tons we need. And how much the per truck takes? 60 ton or 50 ton or maybe the big ton. So then you calculate, and then you calculate the cost. So that's how you can use it. Thank you guys, and have a nice day. Bye.